Hello students, good evening all. So welcome to our next session. So in our previous sessions, we just finished our chapters of linear inequalities as well as quadratic equations. So now in today's session, we are going to start a new chapter, a new topic, that is permutations and combinations. Right. So in our today's session, we are not directly getting into our concept of permutations and combinations. So before discussing about the permutations concept, we just have a quicker look over the background of it, whatever the what is about the factorial and all, and we'll be solving questions related to that, and then we'll jump into our concept of permutations and combinations. Right, so first we'll just have a quick overview of the concepts that we are going to discuss in our today's session of permutations and combinations. So first we are going to start with the basic principles. Right, so as I mentioned, we are not directly jumping into our concept of permutations. So we just discuss about the background of it first, and then we are going to enter into our exact concept of permutations. Right, so before getting into that, we should be aware of some fundamental principles. Right, so the first fundamental principle which we are going to discuss is multiplication principle. Right, so what is this multiplication principle and all, we'll just discuss in a few minutes. So after that, another fundamental principle we are having is addition principle. So both of this multiplication and addition principle are very, very important when it's coming to our permutations and combinations, because using these principles we can actually answer a lot of questions there. Right, so that's why we should be aware of our first foremost, that is fundamental principles which we are having, that is multiplication principle and then addition principle. And the next concept that we are going to cover is factorial notation. So we'll be seeing what is this factorial, like how we are going to represent the factorial and all the basic definition of it, and what and all the properties which are related to factorial. So which are nothing but the factorial properties. And while dealing in this, we'll even discuss some shortcuts where we can easily get the factorial value and all. So these two are together our factorial notation as well as factorial properties. So once we just had a discussion on the background of our permutations, and then we are entering into the concept of permutations. Right, so here in the permutation concept, we'll be having two branches, like two kinds. So one is with repetition. So one type is with repetition and the other one is without repetition. So for these two, we again have different concepts, like we will be having different formulae. So that we are going to see here. So in this permutations, we will be having two branches. One deals with the with repetition and the other one deals with the without repetition. And once we enter into our permutations concept, we will be having some results. Right, so we will be discussing about the important results or the properties which are related to the concept of the permutations here. Right, so these are the basic concepts which we are going to discuss in our today's session. So first four are a quick background for our, like a base for our permutations, and then we are just entering into our concept of permutations, and then we'll be discussing these two types, one with repetition and the other is without repetition, and then we'll be seeing few important results. Right, so along with that, for each and every corresponding concept, we'll be solving questions. So let's start with the today's session. So the first one we are having here is fundamental principle of counting. Right, so as I mentioned, we'll be discussing with our fundamental principle of counting. So in that, we'll be having two principles. The first one is multiplication principle and the other one is addition principle. Right, so the first one we are having is multiplication principle. So let's quickly have a definition. So if one experiment has n possible outcomes and the other experiment has n possible outcomes, right? So then there are m into n, that is m cross n possible outcomes when the both of these experiments are performed simultaneously, right? So when we are having two events, so here we are having two experiments, so one has n number of possible outcomes and the other experiment has m number of possible outcomes, right? So when we are actually performing both the experiments simultaneously, then the possible total number of possible values which we'll be having is m cross n, right? So these will be our total possible outcomes. So for suppose, let me give you an example. So here I am having some 4 digits 1, 2 and 3, 4. So using these 4 digits I am going to form a 2-digit number. So what will be our total possible outcomes here, right? So here in this I'll be having how many here? So here I can have 1, 2, 3, 4, right? So likewise we can just use to solve this, we can use our trial and error method, right? So if we see for this m n cross, so let's just quickly have an example. So yeah, so before discussing the example of a multiplication principle, so let's have a discussion about addition principle also. So the second fundamental principle of counting is addition principle, right? So if one experiment has n possible outcomes and the other has m, so here also the same thing, but here also we are having two experiments. One has n possible outcomes and the other has m possible outcomes. But here the condition is when these two, what will be the possible outcomes when exactly one of these, right? So here exactly one of the experiment is performed, then the total outcomes will be m plus n. So for our initial case, that is for our multiplication principle, there we'll be performing both the experiments simultaneously. So whenever we'll be performing both the experiments simultaneously, then we'll be using our multiplication principle, which is m cross n. If we are performing exactly one of the experiment, then the total number of outcomes will be followed by our addition principle, which will be m plus n, right? So let's quickly have few examples or questions related to our fundamental principle of counting. So here comes the first one. A hall has 12 gates. In how many ways can a man enter the hall through one gate and come out through a different gate? So how many possible ways we'll be having for this question? So here what are our two experiments? One is, our first experiment is entering the gate and the second experiment is exit. So these are our two experiments. So one is entering through the gate and the other one is exit through a different gate, right? So here how many total gates we are having for enter? That means for case 1, how many possible outcomes? Here a hall has 12 gates, which means total entry gates are 12, which means here we will be having m possible outcomes for our first experiment. So similarly, if we check for the second experiment, like how many gates will be there for exit. So here if you observe the condition which they have mentioned, so a hall through one gate and come out through a different gate. So if a man goes through a gate 1, he can exit from any of the gate 2, 3, 4 and so on until 12 except the gate 1. Which means when we have 12 entry gates, the exit gate will be having 12 minus 1, that is 11 possible outcomes, right? So let's just compare to our fundamental principle of counting now, right? So here we are having two experiment 1 and experiment 2. Experiment 1 is nothing but entry of the gate and experiment 2 is nothing but exit. So how many possible outcomes we are having for the first experiment? That is 12, and for the second, the possible number of outcomes is 11. So now if you observe, we have to identify whether these two experiments are performed simultaneously or else only one of these experiments is performed, right? So here one is entry and the other is exit. So if you observe here, both the entry and exit, so both will happen, right? So here the question is, when a man enter through the hall through one gate and come out through a different gate, which means he is here, the both the experiments 1 and 2 are performing simultaneously. So a man is entering through one gate and he will be coming out through another different gate. So both the experiments are performed simultaneously here. Right, so if both the experiments perform simultaneously, which fundamental principle of counting we will be using here, which is nothing but multiplication principle. So here this is m number of outcomes and this is n number of outcomes. So according to our multiplication principle, what will be the total possible number of outcomes, which is nothing but m cross n, which means 12 cross 11. Right. So 12 cross 11 will be our final answer here. Right. So the only thing we have to identify here, that is whether it is whether the two experiments are performed simultaneously or they are performing exactly one of those experiments. So that is the thing we should be aware of. So here it is a multiplication principle. So m cross n, that is 12 into 11, which is 132 ways. So here the total number of ways. So the question is, in how many ways a man can enter through a gate, the hall through a gate and come out through a different gate. So the total number of ways is 132 ways. So here this question is our application of our fundamental principle of counting. Right. So I hope you guys got an idea how to apply the fundamental principle of counting. So let's just do few more questions. So here comes the other one. So quickly try and answer the question. So read the following question. So in this we are having two parts. So you can read it carefully and try and answer it. So same thing, we have to identify which fundamental principle of counting we can apply, and then we can directly apply that. Or else without that also you can just simply, by common sense, you can simply solve it. So let's read the question. So how many numbers between 10 and 10,000 can be formed by using the digits 1, 2, 3, 4, 5 if no digit is repeated in any number? So the first case is no digit is repeated here, and the second case is digits are repeated. Right. So here the numbers are in between 10 and 10,000, which means how many number digit we will be having? 2-digit number, 3-digit number and 4-digit number. So likewise we will be having 3 cases. So how many digit number? So let's see the first case. So we will be having 2-digit number. So let's check for number of ways for 2-digit numbers. So this will be a 2-digit number, ones and tens place. So here it starts from 10. So here we can have all the 5 numbers. So here we can have 2, we can have 3, we can have 4 as well as 5. So how many chances we are having for the tens place? 5. Right. Similarly for ones place here, how many chances we will be having? So once we fix one number amongst these 5, how many numbers will be remaining with? 4 numbers. Right, here they have mentioned in the question no digit is repeated. So the digit which is fixed in the tens place, it cannot be used again. So we'll be having here only 4 chances. Right, so now the thing is, amongst these 5, that is our first experiment having 5 outcomes and the second experiment is having 4 outcomes. Right, so now we have to check whether these two experiments are coming simultaneously or amongst these two only one of the experiment is happening. So if we could get that part, we can identify which fundamental rule of counting we can apply here, either multiplication or addition principle. Right. So here what is our first experiment? The number of ways for the tens digit, and the second experiment number of ways for the ones digit. So our m outcomes is 5 and n outcomes is 4. So if you observe, it's a 2-digit number. So both the cases will occur simultaneously. So tens digit should also be coming as well as ones digit also. So here both the experiment 1 and 2 will be performed simultaneously. So here the number of ways for 2-digit number is nothing but m cross n, that is 5 cross 4, which is equal to 20. Right, so similarly we can check for number of ways for 3-digit number. So can you guys quickly write for this number of ways for 3-digit number? Same methodology you can apply here. So 3-digit number. So initially we have ones and tens place. So now we'll be having ones, tens and hundreds place. So here how many digits we are having? So 1, 2, 3, 4 and 5. So in total 5 digits. So in our 100 place, how many number of outcomes it's possible here? So 5. So again in the first case, no digit is repeated. Right. So here 5 chances. So here 1 digit amongst these 5 digits fixed here. Then we'll be remaining with 4 digits here for the tens place. Right. So again, if we jump into our ones place, again amongst this 4 digit, 1 digit will be fixing in the tens place. So how many digits are already fixed here? 1 and 2. So remaining digits will be taking place in the ones place, that is 3. So again, to form a 3-digit number, all these 3 experiments has to be performed simultaneously. That means for hundreds place, for tens place as well as ones place. So all these 3 experiments must ensure they should be performed simultaneously. So again, it will be the application of our multiplication principle. So it will be 5 cross 4 cross 3. So the number of ways for 3-digit number is nothing but 6. So similarly, we can write for the 4-digit number. So number of ways for 4-digit number. Same methodology here. So ones, tens, hundreds and then thousands place. So quickly let me know the answer. So same thing will be applied here. So here it will be 5 digits. Amongst 5, 1 will be fixed in the thousands place. So remaining 4 will be here. And amongst 4, 1 will be fixed in the hundreds place. And then 3 chances for the tens place. And amongst 3, 1 will be fixed in the tens place. And the ones digit will be having only 2 chances. So again, all these 4 experiments. So each of these 4 experiments has to be performed simultaneously. Then only we could able to form a 4-digit number. So what are the number of ways to form a 4-digit number using the given following 5 digits 1, 2, 3, 4 and 5, and the condition is no digit is repeated. So this will be again 5 cross 4 cross 3 cross 2. Right, that means 60 into 2, that will be 120. So our question is, we have to check for in between 10 and 10,000. So that's what we have done it here. So total number of ways here we are having 20 plus 60 plus 120. So that will be equal to 200. So for the first case, the answer, the number of total number of ways will be equal to 200. So can you guys give a try for the second case here? So it's the same thing, the methodology will be same, but here we will be considering the repetition of the digits also. So we have to consider from 2 digits to 4 digits only, because it is in between 10 and 10,000. So for the first case, the answer is 200. So the total number of ways is 200. So can you guys answer for the second case here? So here also same cases. So number of ways for 2-digit number and number of ways for 3-digit number. And the last one, number of ways for 4-digit number. So 2-digit, 3-digit and 4-digit. So let me check for the answers. So here for the second condition, digits can be repeated. So repetition is allowed here. So for the forming of 2-digit number using the given 5 digits 1, 2, 3, 4 and 5. So for the tens place, how many possible ways? So all the 5 can be possible here, that is 5. Similarly for the ones place, so initially it is the condition is digit is not repeated, but now it can be repeated. Even here if 1 is fixed, we can have 1 again here. Even if it's 2 is fixed, we can have 2 here. Same thing. So the digit can be repeated, which means we can have numbers like 11, 22, 33, like that. So even for the ones place, there are 5 possible ways. So now to get this 2-digit number, so here tens place is our experiment 1 and ones place is our experiment 2. So m number of outcomes for first experiment is 5 and for n number of outcomes for the second experiment is also 5. So we have to now check whether these two experiments has to be performed simultaneously or amongst these two experiments, only one will be occurred. Right, so here to form a two-digit number, both tens place and ones place, both should be required, right? Which means both the experiment 1 and 2 will be performed simultaneously. So here we'll be applying our multiplication principle, which turns out to be 5 cross 5, that is 25. Similarly for three-digit number, so here 5 chances, same as its repetition allowed, 5 and 5. So all these three experiments has to be performed simultaneously. So multiplication principle of counting. So 5 into 5 into 5, 125. Right. And for the next one, four-digit number, again the same thing here. 5 chances and 5, 5, 5. So all four places, all four experiments has to be performed simultaneously. So it will be 5 cross 5 cross 5 cross 5, which is 625. So now if you check, here we are having three experiments. So the number of ways for 2-digit is experiment 1, and the number of ways for 3-digit is experiment 2, and the number of ways for 4-digit is experiment 3, for example. Right. So if we consider, so we'll be checking. So for this, the total number of outcomes 25. For experiment 2, the total number of outcomes 125. And for experiment 3, the total number of outcomes here are 625. So now here we have to check whether the experiments 3 here will be performed simultaneously or one amongst these three will be performed. Right. So now you can see, can we have a 2-digit and 3-digit number at the same time simultaneously? Not possible, right? So here either we can have a 2-digit number, or we can have a 3-digit number, or we can have a 4-digit number, which means here amongst the given experiments, one of the experiment will be performed at a certain time. So now it will be coming under which fundamental principle? When we have amongst given experiment only one will be performed, it will be coming under our addition principle of counting. So according to addition principle of counting, the total number of ways should be added. So now the total number of ways for this question, when the digits can be repeated, it will be 25 plus 125 plus 625, which is equal to 775. So the total number of ways or the outcomes for this when digits can be repeated is 775 ways. Right, so here in this question we have considered our both the fundamental principles of counting, the multiplication principle as well as the addition principle. So I hope now you get an idea of this fundamental principle of counting. So let's do one last question and then we'll jump into our next concept. So here comes the next question. So read the question carefully and try and answer this. So quickly read the question and answer this. It's also related to our fundamental principle of counting. So okay, you can easily answer this. So let's read the question. So there are three stations here, A, B and C. So here there are three stations A, B and C. So 5 routes for going from station A to station B. So there are possibly 5 routes here. We can go from station A to station B, and 4 routes for going from station B to station C. So we are having stations like this, 3 stations A, B and C. Right. So from A to B, how many routes we are having? 5. So let me draw the 5 routes. 1, 2, 3, 4 and 5. So here I am having 5 routes so that I can go from station A and reach station B. 5 different routes. Similarly, from station B to C, I am having 4 routes. 2, 3 and 4. So 1, 2, 3, 4 and 5. 6, 7, 8, 9, let it be. Right. So we have to find the number of different ways through which a person go from A to C via station B. So how can we go? So we can choose a path 1 here from A to B, and we can choose path 6 from B to C, or path 7, path 8 or path 9. So for one path from A to B, we'll actually have 4 chances, 4 possible ways, so that he can go from station B to station C. Right. So for 1, we are having 4. Again for 2, second path, we'll be having 4 ways. Again for third path, 4 ways. Again for fourth path, 4 ways. Fifth path, 4 ways. So in total, how many total ways we are having? 5 plus 4, 20 ways. So if we, in general, if we just solve it by the question, it will be 20 ways. It's easy when we apply our principle of counting. That is fundamental principle of counting. So here if you see, from A to B, it's one experiment, and from B to C, it's another experiment. So for A to B, how many possible outcomes? 5. And for B to C, how many possible outcomes? 4. So now we have to identify whether these two experiments, that is A to B and B to C, will be performed simultaneously, or amongst these two only one will be performed. Right. So according to the question, a person has to move from station A to station B through station A to station C through the station B, which means both these experiments has to be performed simultaneously. So when we perform experiments simultaneously, which fundamental principle of counting will be applicable here? Which is nothing but multiplication principle of counting, which means 5 cross 4, which is equal to 20 ways. So the same thing we got here, the same answer. Right. So find the number of ways through which a person can go from A to C via B is nothing but equal to 20 different ways. Right. So this is how we'll be using the fundamental principle of counting, and we can easily answer the questions related to that. So let's move on to the next concept. So far we have discussed our fundamental principle of counting, where we have focused on multiplication principle as well as the addition principle. So now let's jump into the next concept. So the next one which we are going to discuss here is factorial. Right. So we should be aware of this factorial notation and the definition and the representation of it, because when it's coming to our permutations, we'll be majorly using this factorial notation there. Right. So that's why, as a background, before getting into the concept of permutations, we should be aware of the factorial notation here. So let's see the definition first. So the product of first n natural numbers is generally written as n factorial. So this is the symbol or the representation which we'll be using for factorial. So this is the representation of factorial. So when we do product of first n natural numbers, that is nothing but n into n minus 1 into n minus 2 into, so natural number starts from 1, so until 1. So product of first n natural numbers is nothing but, in general, it will be represented or written as n factorial. Right, and we'll be reading that as n factorial. So this is the representation of factorial. So basically n factorial is nothing but product of first and natural numbers, which is given by n into n minus 1 into n minus 2 and so on until 1. Right. So let's see few properties related to the factorial. So when we have n factorial, so when we have n factorial, so what is our expansion of this n factorial, which we have seen just now? This can be written as n into n minus 1 into n minus 2 into n minus 3 into and so on until 3 into 2 into 1. So this can also be represented as n into, so this from n minus 1 until 1, that is nothing but, can we write it as n minus 1 factorial? Yes, right. So we can represent this entire thing as n minus 1 factorial. So the general representation of n factorial can also be represented as n into n minus 1 factorial, or we can even write this as n into n minus 1 into, so from this I can separate it, that means n minus 2 factorial, or else I can separate it from n minus 3, then it will be turning out to be n into n minus 1 into n minus 2 into n minus 3 factorial. Right, so likewise according to the required condition we can write it in different number of ways. Right, so this is our first and important factorial property. And coming to the next, so if we have 1 factorial, the value will be equal to 1 because it is 1 into 1, that's it. If we have 2 factorial, what is the expansion of it? So it starts from 2 and it will go until 1, so 2 into 1, 2. Right. So now what happens if we have 0 factorial? So many of us think that when it's 0 factorial, the value will be equal to 0. But it's not the case when we have factorial. So the another property, and which is very important here, it's nothing but our 0 factorial is nothing but equal to 1, similar to the 1 factorial. And the next property here is factorials of negative numbers are not defined. So by the definition of factorial itself, we can predict that it's nothing but it's a product of first and natural numbers. Right, that means we cannot have any negative integers. So factorials of negative integers are not defined. Right, here we are having the other one, that is 2n factorial. So how can we write and expand this 2n factorial? 2n factorial will be equal to 2n, 2n minus 1, 2n minus 2, 2n minus 3 and so on. We can express it, right? So if we do the product and all, we can take actually 2 power n common, right? And it can be written as 2 power n into n factorial into the odd numbers, that is 1 into 3 into 5 and so on, 2n minus 1. So it's a product of the odd numbers here we are having. So if we are having 2n factorial, that can be simply expressed as 2 power n into n factorial into. So instead of writing this entire expression of 2n into 2n minus 1 into 2n minus 2, 2n minus 3 and so on. So instead of writing this huge expansion of 2n factorial, we can represent that in another way, that is given by 2 power n into n factorial into 1 into 3 into 5 and so on to n minus 1 until 2n minus 1, that is odd numbers. Right, so this is our expansion of 2n factorial. So now let's do a very basic level of questions which are related to the factorial here. So I hope you guys can answer this. So quickly do it and let me know the answer. So far no one has given answer, so quickly do it, guys. So what's the answer for the first one here? The first bit we are having is evaluation of 5 factorial. So let's see. So how we'll be writing? So if it's a n factorial, what is our expansion, guys? So it is n into n minus 1 into n minus 2 and so on until 1. Right. So the same thing here. So here the n value is 5. So how we'll be writing? So 5 factorial expansion will be 5 into 5 minus 1 will be 4. So 4 into again 5 minus 2, that is 3. So 3 into 5 minus 4. Sorry, 5 minus 3, that will be 2. So 2 into 5 minus 4, that is 1. So until 1 we can stop it. So the 5 factorial value will be equal to 5 into 4 into 3 into 2 into 1. So similarly you can write for the 7 also. So the value we can write it here. So 5, 24. So 24 into 5, it will be 120. So the value of 5 factorial here will be equal to 120. So similarly you can find for 7 factorial. So once we could able to find these two 5 factorial and 7 factorial values, so third one will be the same thing. So no one has answered it. So if you guys require more time, you can just let me know so that I can wait for few more minutes. So what's the answer for the second one? 7 factorial. So let's see what is the expansion of it. So the same way, so it will be starting from 7 until 1. So it will be 7 into 6 into 5 into 4 into 3 into 2 into 1. Right, so the entire product of 7 cross 6 cross 5 cross 4 cross 3 cross 2 cross 1. So that will be equal to 5040. And once we got our first two bits, so the third one is nothing but simply the using of first and second. So 7 factorial minus 5 factorial. So value of 7 factorial, it's 5040 minus 5 factorial 120, which will be equal to 0, 2, 9 and 4. So it will be 4920. So here we are just evaluating the values. So the value of 5 factorial is 120 and 7 factorial is 5040 and 7 factorial minus 5 factorial is equal to 4920. That's all. So let's move on to the next question. So here comes another type of evaluating the values related to the factorial. So initially we just had a simple expansion or simple evaluation. So now we are having a different format. So try and do that. So as it's a numerator and denominator part, so now we can actually apply our factorial properties which we have seen in the previous slides, so that we can just cancel some terms here. So that's why we have already seen our factorial properties which we can apply in this particular question. So quickly guys, quickly answer this. Okay, someone has already given the answer. First one 42, correct. So Dinesh has given the answer for the first one, 42, perfect. So what about the second one? So Dinesh already given the first one. So let's see for the second one. So if we could apply our factorial properties, we can get the answer. Okay, Dinesh has already given second one also. So I'll just quickly do the solution here for those who are just trying it. So we are having 7 factorial by 5 factorial. Right, so the denominator value is less, so we can actually cancel it. So our 7 factorial can be written as 7 into 6 into, so instead of 5 into 4 into 3 into 2 into 1, I can write that as 5 factorial. So as we have seen in our factorial properties. And in the denominator, we already have 5 factorial. So these two terms will be getting cancelled. So the answer will be 7 into 6, which is equal to 42 for the first one. Similarly, for the second one, it is 12 factorial by 10 factorial into 2 factorial. So same property will be applicable here also. So this can be written as 12 into 11 into. So instead of writing this 10 cross 9 cross 8 and so on until 1, we can represent that with and 10 factorial, which is nothing but our application of this property, which is this can be written as n into n minus 1 factorial, or else we can write it as n into n minus 1 into n minus 2 factorial and so on. So in the denominator here, we are having 10 factorial into 2 factorial. So this 10 factorial will be getting cancelled, and then it will be remained with 12 into 11 by 2 factorial. So 2 factorial is nothing but 2 into 1. So this will be getting cancelled 6 times, which is equal to 6 into 11, which is 66. So these are the answers for the first and second, 42 and 66. So let's move on to the next question here. So here they have given some expression and you have to evaluate. So they have given in variables of n and r, but both the values of n and r are given in the question. So just we have to do the substitution here and we have to do the further simplification required. So quickly do it and let me know the answer. So you'll be seeing this expression a lot when we are moving ahead into our concept of permutations. So for the practice, I just dumped a question here which is related to that. Or if anyone solved it, you can let me know the answer. Okay, Dinesh already given the answer. Perfect. 10. So let's just do that. So here the expression which is given is n factorial by r factorial into n minus r factorial. And here in the question itself, they have given the values of n and r. So let's do the simple substitution here. So n is 5. So it will be 5 factorial in the numerator and r is 2. So 2 factorial in the denominator and n minus r, that is 5 minus 2 factorial. So this will be equal to here 5 factorial in the numerator and 2 factorial. So 5 minus 2 will be 3 factorial. So again we can apply our properties of factorial which we have discussed. So 5 factorial can be written as 5 into 4 into 3 factorial divided by 2 factorial into 3 factorial. So this entire 3 factorial will be getting cancelled and we'll be remaining with 5 cross 4 by 2 factorial. So 2 factorial expansion is nothing but 2 into 1. So again 2 times it will get cancelled, which will be remaining with 5 cross 2, which is equal to 10. So the value of this given expression n factorial divided by r factorial into n minus r factorial, when n value equal to 5 and r value equal to 2, will be equal to 10. So let's move ahead with the next one. So here comes the next question. So here in the expression they have given an unknown value, unknown variable x, and you have to figure out the value of x here. So let's see. So you just have to apply our properties and you have to simplify it to get the variable value x variable here, value of it. So the expression given here is 1 by 8 factorial plus 1 by 9 factorial is equal to x by 10 factorial, and we have to get the value of x. So here, while dealing with this factorials, what we have seen our property, which is n factorial can be represented as n into n minus 1 factorial and all. So when you observe the numbers which they have given for the factorial, it will be easy when we express all the factorial in the lowest number which is given here. So in these typical types of equations where we have to find the variables. Right, so here what are the factorials they have given? 8 factorial, 9 factorial as well as 10 factorial. So amongst these three, which is the lowest one? So 8 factorial is the lowest one. So here we cannot express 8 factorial in terms of 9 factorial and 10 factorial. Whereas we can express and convert the given 9 factorial and 10 factorial into 8 factorial. Right, so 9 factorial and 10 factorial can be converted in terms of 8 factorial, whereas 8 factorial cannot be converted in terms of 9 and 10. So here our first thing to do here is to convert the 9 and 10 factorials into in terms of 8 factorial. So that will be our first step here. So now I get you got an idea how to start the thing. So now you can give it a try and let me know the answer. So once we express that in terms of, once we express our 9 factorial and 10 factorial in terms of 8 factorial, then it will be easy to get our variable value x. So Dinesh has given 180. So can you check once your answer, Dinesh? So it is not 180. Maybe there might be a calculation error, something like that. You can just go through your solution once again and rectify it if any wrong you can done. You can just rectify the error and let me know. So just now, as I mentioned, we'll be rewriting 9 and 10 factorial in terms of 8 factorial. So let's do that first step here. So 1 by 8 factorial will be remaining as it is, whereas 1 by 9 factorial can be written as 9 into 8 factorial. Yes or no? Similarly, x by 10 factorial can be written as 10 into 9 into 8 factorial. So this will be our first step here. So now if you observe all those three terms, so 1 by 8 factorial, 1 by 9 into 8 factorial, and x by 10 into 9 into 8 factorial. So if I observe my left hand side of the equation, I can take 1 by 8 factorial as common. And what will be the remaining term here? So 1 plus 1 by 9. Similarly, what about my RHS here? This can be written as 1 by 8 factorial can be pulled out and we can write this as x by 10 into 9. Yeah, now it's correct, Dinesh. 100. Perfectly correct. So now 1 by 8 factorial will be get cancelled. So that's why I mentioned whenever we are having the lowest term, if we could express in the lowest term, it will get cancelled when we are doing something like this types of equations. So now we have remained with our general equation in one variable, that is 1 plus 1 by 9. That is, if we take LCM here, it will be 10 by 9. It will be equal to x by 10 into 9. So here both the denominators 9 will get cancelled and the value of x here will be equal to cross multiplication, that is 10 into 10, which will be equal to 100. So the unknown variable value, that is the value of x in the given equation, is equal to 100. Right. So this is how we can easily solve our given equations or things related to factorial by application of our properties of properties related to the factorial. So far we have discussed a background related to the permutations. So permutations and combinations. So in our next sessions, we directly getting into our main subject, that is our main concept of permutations and combinations. So in our today's session, we just discussed about our fundamental principle of counting, and then we have discussed the factorial and the properties related to factorial, and for each of the concept we have done questions related to that. So that's all for today, guys. So if you have any doubts and questions, you can let me know in the comment section. So that's all. So we'll just start with our permutations concept in our next session of permutations and combinations. Thank you.